Okay. So it's truly my great pleasure to introduce Martina Galeano to you all. She hails from Mendoza, Argentina, where she was born and raised, and she received her BS in enology from Universidad Maza. In 2010, she completed her first harvest in Stellenbosch, South Africa at Kolenhof Winery. And she subsequently interned at Tepiz in Mendoza in 2011. And she was offered an assistant winemaker position at that point. And during this time, while at Tepiz, she also did 2 harvests in Napa. So she was no stranger to California when she came here at Providence Vineyards. And after only a few years at Tepiz, she was promoted to associate winemaker and charged with overseeing the building and management of a new winery in the renowned Eco Valley region of Mendoza, a renowned wine region of Mendoza. And also this time through these experiences, she very smartly realized that, especially with changing climates and future reduction in resources such as water, that it was really important for her to have a better understanding of viticulture, plant biology, and physiology to continue making high-end wine. And so in true Martina style, she not only decided to do that through her current position or through local education, but she searched internationally for positions and applied for fellowships and was awarded a Fulbright scholarship through the Argentinian government. And luckily for us, she decided to come to UC Davis, to the VEN department, and there she approached Andrew Malcarone and discussed projects with him, and I was lucky enough to be roped into it too. So she started working on a joint project between my lab and Andrew's lab, looking at the effect of heat waves on irrigation practices on grapevine physiology and berry chemistry, and the influences on wine chemistry and sensory properties. Since coming to Davis a year and a half ago now, she has already completed an entire field season, which she pretty much single-handedly managed, and also devised methods for work with others to devise methods for doing the wine chemistry and otherwise. Received several scholarships and fellowships, including the Wine Spectator Fellowship or Scholarship, and has really done a phenomenal job coming here and right off the bat becoming a really important member and community of my lab, Andrew's lab, and the VEN department at large. So she will be presenting that work from this past season and will also be continuing on, I hope, as long as she doesn't finish too quickly, continuing on and doing a subsequent season of sampling this summer. And then plans, unless I can convince her and the Argentinian government to stay here and do a PhD, she plans in the fall to return to Mendoza and likely work for Tepiz, but her aim is to take the knowledge that she gained from this work and really expand both Tepiz's programs in terms of climate change research, in terms of adapting new management strategies and looking at new cultivars. And I have no doubt there that she will be a really a national and global leader in terms of thinking about how to adapt to climate change. So I'm very excited about her. On a personal note, as I said, she's been such a phenomenal member of the community and the lab. And the only complaint that I have about her is that she has set my expectations so high and really to an unattainable level, I think, for my future graduate students. And so with that, and without further ado, I introduce Martina to discuss her research on heat waves and irrigation practices.
Well, thank you so much, Beth, and I appreciate the kind words. It's been an amazing introduction. And as Beth previously said, I'm gonna be talking today about the effect of heat waves and irrigation practices on grapevine physiology and berry chemistry. This is a brief outline of what I'll be covering today. First, I'll talk about the effects of climate change in California, and I'll go over the aims of the study. And then I'll focus mainly on the experiment itself. We'll talk about the field site, experimental and sampling design, as well as the different measurements that we did and when we carried those out. And then we'll go over some results that we took the last season regarding physiological responses, yield, very primary and secondary metabolites. And finally, we'll cover some of the conclusions that we drew from this first year of the experiment and future directions for this coming season. So in the near future, we're going to be facing challenging climatic conditions, and understanding how the vine responds to these conditions, as well as its plasticity to adapt under challenging environments, can help us make better management decisions under this new scenario. Looking at some historical weather data in California, we can see that we are already experiencing some of these changes in climate. And these two plots here, they show the average maximum and minimum temperature over the summer months of data collected from 135 weather stations around California from the years 1950 to 2010, so around 60 years of data. And we see a trending increase of both maximum and minimum temperature over the years, as well as a decrease in diurnal amplitude between day and night temperatures. For California's future, we are looking at an increase in heat and water stress over the next few decades. The two maps here, they show model predictions for the years 2007 to 2099. And the map on your left shows the increase in the frequency of 3 consecutive days with maximum temperatures above 38 Celsius or 100 Fahrenheit, which in this study is what we define as a heat wave. So we are looking at the increase in heat events. And the map on your right shows the increase in evapotranspiration over the summer months. So by the end of the century, we are looking at a higher water demand from the atmosphere caused by these warmer conditions that will generate higher evapotranspiration in the plants, exposing them to higher stress. Now I want to focus in Lodi, where the experiment is being carried out, and I just wanted to translate some of the data that I just showed you from California to this region. And the two plots on the top, they show that in the last 30 years, again, the maximum, average, and minimum temperature during the growing season have increased. And this increase is more drastic when we compare it with data from California, especially when looking at maximum temperatures. And at the bottom, we have the model predictions for Lodi for the mid-century and for the end of the century. And this is looking at the increase in the number of days with maximum temperatures above 38 Celsius. And by the end of the century, the number of days under this extreme temperature is going to be pretty drastic. And the good thing about carrying out this experiment in Lodi is that it's a region that is going to experience much of these changes in climate, as well as higher frequency of heat events sooner than other wine growing regions here in California. And this can help the wine industry to foresee upcoming challenges, as well as cultivars that might have better plasticity to adapt under these extreme temperatures. Regarding the aim of the study, we wanted to evaluate the impact that pre-heat wave irrigation practices had on grapevine physiology and berry chemistry, and subsequently on the wine chemical and sensory properties. And we also wanted to understand how water can help mitigate the effects of these heat events and lead to a more efficient use of water. And finally, we wanted to provide better tools for the wine industry to moderate the effects of heat events and evaluate a potential shift in the wine sensory profile. And nowadays, what happens is that there is really no consensus regarding what the best strategy is to face an upcoming heat event, beyond the fact that growers irrigate as much as they can prior to a heat wave to get a higher evaporative cooling at the canopy level, but the effects on the plant on a physiological and metabolic level are unknown. So this is a collaborative project that we're carrying out with E&J Gallo. The field site where we're doing the experiment is Borden Hills Vineyard. It's in Herald in northeastern Lodi, close to Galt. And it has 23 acres of Cabernet Sauvignon that was planted in 2010. The rootstock is 1103P. And the yield in the last 6 years has been approximately 5 tons per acre. The trellis system that we have in this vineyard is a bilateral cordon with a single high wire, as you can see in the middle picture. And it doesn't have any support wires for the canopy, so the canopy falls to the side, as we can see in the image on the left. And Pretty much all vineyards operation in this block are mechanized, so pruning, hedging, deleafing, and harvest are mechanized. And what makes this site particular and actually allowed us to carry out our experiment is that it's divided into 98 square pixels of 30 by 30 meters with a variable rate drip irrigation system, allowing differential irrigation on each individual pixel. And these white boxes that you see here, they are all distributed all across the block. And here I have a better diagram of the irrigation system itself. And these are the white boxes that I was mentioning that are connected to the main supply of water, as well as a solenoid valve. And whether these boxes are signaled remotely to open or close this valve, they allow irrigation in each individual pixel. Regarding the experimental design, we implemented 3 treatments during the 2019 season. A first treatment that was the baseline treatment and was held at 60% ET. This one was underwater deficit, and those are the yellow or green squares, depending on the screen. A second treatment where irrigation was double the baseline, and we call it 2X, and this one was the blue one. And a third treatment where irrigation was 3 times the baseline, and we call it 3X, and those are the purple squares. And the important thing to point out here is that this differential irrigation was applied only during certain periods of time. So we started these treatments 2 days prior to a heat wave, and we continue until 1 day after the heat event. Aside from that, the irrigation schedule for the 3 treatments was kept the same. We had a total of 4 reps per treatment, but we took only measurements on 3 blocks per treatment, and we kept one of the replicates as a backup. And ET was estimated using NDVI, Landsat data, and crop coefficient. Well, these are the measurements that we took throughout the season, and to monitor physiological responses, we look at net photosynthesis, stomatal conductance, stem and leaf water potential, and leaf temperature. And for barochemistry, we analyzed Brix, pH, titratable acidity, and skin phenolics. We mainly focus on anthocyanins and tannins, but I'll go over the extractions and analysis that we did for these secondary metabolites in more detail in a couple of slides. And yield-wise, we look at kilograms per plant and number of clusters per plant. So when did we sample? For physiological measurements, we did diurnal measurements from early July to the end of September at around weekly intervals. 2 of these diurnals, we did them before any heat event happened, so we consider them as our baseline for all of our treatments. And then we did diurnals pre, during, and post heat wave, and a final one that was pre-harvest. And to monitor physiological responses, we randomly selected 6 vines per plot, and I'm gonna go back really fast to the experimental design to show you really quickly. The vines that are with the black square are the vines that were selected to monitor physiological responses, and the ones that are with the pink square are the ones that were selected to sample berries for barochemistry, and they are all distributed in each plot. And for barochemistry, we had a total of 9 vines per plot, and we started sampling from 50% variation until harvest at regular Brix intervals. And also when a heat wave happened, we sample again pre, during, and post heat wave. And finally, we made wines from these blocks, having a total of 3 fermentations for treatments that we carry out at Gallo's Research Winery. And now we're gonna conduct sensory studies on them, as well as phenolic and aromatic profiles of these wines. And we were supposed to do this during the spring quarter, but this got canceled, and we have to see when we are able to reschedule them. This is a brief diagram of the extractions and analysis that we did for phenolics. As I mentioned before, we work with skin phenolics, so we separated the pulp and the seeds from the skins. We freeze dried them using liquid nitrogen, and we ground them into powder using a tissuelizer. The powder that we got, we transferred it to a jar with 66% acetone solution. We fill the headspace with nitrogen, and we seal this jar. We cover it with aluminum foil to prevent any light exposure, and we put it in an orbital shaker for 24 hours at 150 RPM. And after 1 day of extraction, we separated the solids using a RAF filtration and removed the acetone using a rotovap under vacuum and with a water bath at 35 Celsius. So once we had our grape extracts, we ran analysis on them, and to look at total anthocyanins, we used the modified Summers assay, and to look at total tannins, we used the methyl cellulose precipitation assay. And we carry out these two assays using a 96 well plate format with a microplate reader that allowed us to carry out multiple samples at the same time. And finally, to look at monomeric anthocyanins, we ran reverse phase HPLC. So this study works with natural heat events, and the number of heat waves that we have from 1 year to another is going to be variable. During the 2019 season, we had 2 heat waves. A first one that happened at the end of July and was just before variation. You can see the phenological stage at the bottom of the figure. And a second one that happened around mid-August and was post-variation. In your left y-axis, you can see the daily amount, the daily applied irrigation in gallons per acre. And as I mentioned, you can see when you start having these differential irrigation treatments here, the baseline would be the yellow one again, and is the one that we held at 60% ET. The 2X is the blue one, where irrigation was double the baseline, and the purple one is the 3X, where irrigation was 3 times. And when we didn't have heat waves, we kept the irrigation schedule the same for all of the 3 treatments. Now moving on to the results from last year. First, we'll go over some of the physiological responses. And this is looking at midday stem water potential throughout the different sampling days that we did. And here what we can see is that during heat waves, we really don't see significant differences among the treatments. And also when we compare values of stem water potentials during heat wave on each treatment and values taken pre-heat wave or even before a heat wave took place, we don't see really big differences. We do see a treatment effect post-heat wave, where the baseline has a lower water potential compared to the other 2 treatments. But overall, what I'm trying to say is that we didn't see much stress in these vines throughout the season. And even when we have a treatment effect, these values of stem water potentials are higher when we compare it with other measurements taken other days. Now for leaf water potential, we see a similar trend as for stem water potential. And here, what I'm showing you are measurements taken before the first heat wave, during the first heat wave, and after it. And as I mentioned, we did diurnal measurements. So we started sampling at pre-dawn and continued sampling until 6 p.m. in the afternoon. And we did 5 different rounds of measurements. And at the beginning, as we can see, we don't see really big differences in the treatments. And during heat wave 1, we start seeing some differences during some point of the days, but it's post heat wave where we see a significant lower water potential in the baseline treatment when we compare it to the other 2 throughout the day. And we have a similar trend for heat wave 2, where we start seeing differences during the heat wave that continue post heat wave, but at recovery, the 3 treatments, they don't really show differences. And another thing to point out is that when looking at pre-dawn water potentials, we pretty much didn't see any differences regarding pre-dawn water potentials at any point. It's only one sampling, during one sampling day, we had some differences. Now moving on to photosynthesis and stomatal conductance, I'll just show you results from the second heat wave because it was the longest one and the most intense one. This is net photosynthesis at the top and stomatal conductance, again, throughout the different sampling points that we carry out throughout the day. And here we see a significant reduction of carbon assimilation in the baseline treatment during heat waves. And no really big differences between the 2X and the 3X. And this decrease in carbon assimilation is coupled with a significant decrease in stomatal conductance, which they are extremely linked. Post-heat wave, we start seeing recovery in the baseline treatment and also higher stomatal conductance for all treatments, but still differences between the baseline treatment and the other two treatments. But at recovery, we see a similar trend for the three treatments, despite having some differences during 2 points of the day. So overall, the treatments are able to recover from physiological stress after the heat event. Now this is looking at the relationship of leaf temperature and gas exchange measurements. This is for heatwave 1, and here we have heatwave 2. And again, at the top we have net photosynthesis, and at the bottom stomatal conductance. And again, we have we can see in the baseline treatment a reduced net photosynthesis and stomatal conductance when compared to the other two treatments throughout any leaf temperature. And as well, we see that the baseline treatment is the one that is getting leaves that go to 45 Celsius or even above it. And as we saw in the previous slide, we're seeing that the baseline treatment is having a decrease in stomatal conductance, so it's closing stomata, it's preventing transpiration, and it's preventing the leaves from cooling off, and we're seeing higher temperatures in the baseline treatment. While the 2X and the 3X treatment, we start seeing a cooling effect from having higher irrigation, as well as higher values for both net photosynthesis and stomatal conductance. This is just a brief summary of the physiological measurements that we just saw, and just as a few things to mention, we didn't pretty much see differences between the 2X and the 3X treatment. The main differences that we see them during the heat wave in the baseline treatment, where we have a lower gas exchange measurements as well as higher leaf temperatures, but we see recovery after heat waves from physiological stress. And we see limited responses of stem and pre-dawn leaf water potentials during heat waves. Now, yield-wise, we have a significant decrease in kilograms per vine and grams per clusters in the baseline treatment compared to the other two. And this decrease in yield is mainly related to a reduction in berry weight that we saw. Here we have that from early on in sampling at 50% variation. We already had in the baseline treatment berries of lower weight compared to the other two treatments. So it would seem that heatwave 1 affected berry cell division in the baseline treatment, causing it to have berries of a smaller size as well as lighter berries. And these differences continue throughout the season until harvest. For berry primary metabolites, here we're looking at bricks throughout the different sampling points. And at the beginning, we don't really see big differences in the treatments. It's after heatwave 2 where we see that the baseline starts accumulating sugars faster, and it reaches maturity, which we define in this treatment to be 25 bricks, a week before the other two treatments. For pH and TA, we have, again, similar responses. At the beginning, we don't see really big differences, but it's after heatwave 2 where we start seeing differences. And we have a significant reduction in TA in the baseline treatment that continues until harvest, coupled with an increase in pH in the baseline treatment. And it's the 2X treatment, the one that shows the highest TA and the lowest pH, the lowest pH. And again, just to summarize berry primary metabolites and yield components, we see that we have a decrease in yield in the baseline treatment, mainly related with a reduction in berry weight and not really big differences in the other two. And for berry primary metabolites, the baseline treatment is showing a hastening in maturity, as well as a decrease in TA coupled with an increase in pH, I'm sorry. And the 2X treatment is the one that seems to have the highest TA and the lowest pH, and 3X is in between them. For very secondary metabolites, we'll first go over total anthocyanins. This is looking at total anthocyanins in milligrams per berry. So we're looking at anthocyanin content. And as we've seen in previous figures, we start having differences after heatwave 2. And here we have a significant degradation of anthocyanins in the baseline treatment, while the 2X treatment seems to be the one that has the highest synthesis. And interestingly, we see a reduction of anthocyanin content in the 3X treatment compared to the 2X treatment. And these differences, they continue through ripening. So we start seeing some negative effects in some berry quality traits resulting from adding too much water. And now we have here the correlation between anthocyanins and Brix. There has been previous studies done in Australia and in Siraj where they expose vines to elevated temperatures as well as different water regimens. And what they saw was that despite the vines were under irrigation or under water deficit, the vines that were exposed to higher temperatures started synthesizing anthocyanins at a higher rate and generating this delay in anthocyanin synthesis, as well as a thermal decoupling between anthocyanin production and Brix, which at the end will generate a mismatch between your Brix maturity and your phenolic maturity. So when we plotted our data, we wanted to see if we were having this decoupling from early on, prior to the second heat wave, where we saw that we actually had degradation and these differences became more pronounced. And around 17 or 16 Brix, where we don't have the effects of heat wave 2 yet, we see that at the same Brix level, we already had different anthocyanin content. And again, the baseline was showing the lowest content, followed by the 3x and then the 2x. So there is a decoupling happening from early on, likely related with heat wave 1, which happens so close to variation that could be affecting the anthocyanin or delay in the anthocyanin synthesis in some of these treatments. These are the results that we got from HPLC, and this is at harvest point. And what we did is here we grouped the monomeric anthocyanins based on their number of substituents on the B ring. So whether they were dihydroxylated and they came from one branch of the pathway, so whether they were cyanidine or guanidine based, or whether they were trihydroxylated and they came from the other branch of the flavonoid pathway. So whether they were delphinidine, petunidine, or malvidine based. And as anthocyanins increase in hydroxylation, in methylation, and in acylation, they become more stable molecules against oxidation and thermal degradation. So we would expect that the treatment that was under higher irrigation, which with lower canopy temperatures, would have a higher proportion of dihydroxylated anthocyanins. Here we're looking at anthocyanin percentage. And that's what happens. We see that the 3x treatment, where is the treatment where the most amount of water was added, is the one that has the highest proportion of dihydroxylated, while the other two have a higher proportion of trihydroxylated anthocyanins. So after seeing these results at harvest, we were wondering if these differences were happening from early on. So we took the samples that we had from 50% variation and we ran HPLC on them. And this is from 50% variation. And we saw that the differences were already there. So it is likely that heat wave 1, which, as I mentioned before, happens so close to variation, could be having an effect on the precursors of these compounds or in the expression of genes involved in the flavonoid pathway, producing an upregulation or downregulation of one of the branches of the pathway. So looking at other studies that have been working with pre-variation heat waves, there is a recent publication done by Good et al., where they simulated heat waves in a greenhouse using this complex heating system, but they only work with pre-variation heat waves. And they expose a set of vines to a heat wave just after fruit set, another set of vines to a heat wave 4 weeks after fruit set, and a third set of vines that they exposed to both of them, as well as a control. And what they saw in this experiment is that the vines that were exposed to a heat wave closer to variation end up having a higher percentage of trihydroxylated anthocyanins. So the authors suggested, based on previous research, an upregulation in the transcription of flavonol 3,5-hydroxylase under high temperatures on vines exposed to heat waves close to variation and close to tannin synthesis, which would increase the proportion of trihydroxylated anthocyanins. And then this is coming back to harvest point, and here we just have grouped the anthocyanins differently. We group them on their 5 primary anthocyanins that we find in grapes. And we see the same patterns in hydroxylation. What I think it was important to mention here is that the 2x treatment, which is the one that has the highest anthocyanin content, is also showing the higher proportion of malvidin, which is important from a winemaking perspective, since malvidin is a more stable anthocyanin and also related to more purple and darker colors. Anthocyanins, based on their hydroxylation, they will show different colors. Trihydroxylated would be more related to more purple or blue colors, while dihydroxylated are more related to a red color. And also as well, pH is gonna play an important role in the color of the anthocyanins based on the pH of the solution that they are in. But the 2X treatment seems to be showing better berry quality traits, which we would hope to see then reflected whenever we run the sensory studies on these wines. And finally, this is looking at total tannins. This is again milligrams per berry, so we're looking at content. And we see that from 50% variation, we already had differences, where the baseline treatment was again having the lowest amount of tannin contents compared with the other two treatments. And these differences continue throughout ripening, despite having a decrease due to the interaction of tannin with cell wall components, as well as a decrease in extractability that they show throughout ripening. So whatever differences are happening between treatments, they are happening during tannin synthesis, so from flowering to variation, and to know whether Heatwave 1 had an effect on tannin biosynthesis. Now this year, we're gonna start sampling from fruit set to harvest to see when these lines are actually separating. And now just a brief summary of all the secondary metabolites that we just saw. We had thermal decoupling that we saw between anthocyanins and bricks. The highest degradation of anthocyanins is happening in the baseline treatment, but we also see negative effects on skin phenolic content from either overwatering or underwatering. And seems that the 2X treatment seems to be showing the best performance in the sense that it has this highest skin phenolic content, as well as a higher proportion of trihydroxylated and higher proportion of malvidin. And we also saw that it was the treatment that had the higher amount of TA as well as lower pH, and was able to mature a week later compared to the baseline. And we have changes in hydroxylation due to differential irrigation. We saw that the 3X baseline treatment had a higher proportion of dihydroxylated anthocyanins, which when we take these grapes and we crush them and we ferment them, we're gonna have a higher percentage of anthocyanins that are more susceptible to oxidation. So as some of the conclusions from this first year of the experiment, we saw that vines exposed to different treatments were able to recover after heat waves from physiological stress. And the main influence of heat waves were seen in berry chemistry and yield, where we saw negative effects from working with either excess water or insufficient water applications. And we also saw a higher evaporative cooling in vines exposed to higher irrigation during heat waves, but not big differences between the 2X and the 3X treatment. So for future directions, as I mentioned, for the 2019 season, we still need to run the wine's phenolic and aromatic profiles and the sensory studies. And for the 2020 season, we're gonna be looking at carryover effects from the 2019 treatments, looking at phenology and yield. And we're also gonna be installing a lot of sensors in the field to monitor soil moisture. We're gonna put surface renewal towers to be able to monitor ET on each treatment. There's also gonna be a solar-induced fluorescence tower to be able to estimate or to look at stress across heat waves. Light exposure and leaf and berry temperature sensors to know what's going on inside of the canopy at the cluster level and see if other abiotic factors can be contributing to these differences that we're seeing in metabolites in the berries. And the idea is to be able to link all this sensing data that we're gonna get with all the measurements that we're doing in the field. And as I mentioned before, we're gonna start sampling berries from fruit set to harvest, and finally we'll collect also berries for molecular analysis to look at transcription factors of genes involved in the productions of these metabolites. And finally, this is the new experimental design, since we wanna monitor carryover effects, we had to spread our treatments. Now they are of 60 by 60 meters, and we'll be able to monitor vines that have been previously exposed and vines that have not. We have already started monitoring phenology this year, around a month ago. I think that's pretty much everything that I have for the study. And now my final acknowledgements for everybody involved in this project. First, I want to thank Beth Forrestal and Andrew Macaron, my two PIs, for bringing me into this project, for all your support, your guidance, and help throughout it. Luis Sanchez and Nick Dakuslian from Gallo, who helped us with everything we needed throughout the season. I want to thank James Campbell from the Waterhouse Lab, who helped me with all my phenolic analysis. Lauren Parker, Nicholas Van Bach, Matthew G, Paul Bringas, and everybody in the Macaron Lab who helped collecting data. This project was a huge sampling effort, and we could not have done it without the help of everyone involved here. And my amazing VE cohort, thank you so much, guys, for this incredible 2 years. And finally, the scholarships funding my education, the Argentine Presidential Fellowship in Science and Technology, as well as the Fulbright Commission of Argentina, the Wine Spectator Scholarship, and the Jasper Shield Research Award, and all the sponsors funding this project as well. Thank you so much. And do you have any questions?
Thank you so much, Martina. That was wonderful. If you have any questions, feel free to raise your hand and or speak up, and Martina will take your questions now.
Martina.
Oh.
Hello.
Hi. How long were the first heat wave and the second heat wave? I think you said the second was longer.
Yes. How long they were?
Yes.
I have it right here. Let me just like really check really fast. But it was like a 4-day heat wave. The second one compared to the other one that was only a 3-day heat wave, and also we had higher temperatures.
Okay, and what do you, I guess, define as a heat wave? Does it have to be longer than a certain period?
I'm sorry, can you repeat again? It got kind of frozen.
Oh, sorry. What was the definition used for a heat wave? Does it have to be longer than a certain period? Higher temperatures over a certain temperature?
Yeah, sorry. I should have re-mentioned it. I mentioned it at the beginning, but yeah, what we defined it as a heat wave was 3 consecutive days with maximum temperatures above 38 Celsius or 100 Fahrenheit.
Okay, thank you.
Yeah, no worries.
I don't know how to raise my hand, so I'll just ask the question. It looks like there's quite a big influence of things that happen early. So are you thinking that maybe these heat waves that happen in August are not so important?
You mean by the heat waves that happened before?
Yeah.
Well, I think that you definitely see a big influence in the second heat wave regarding anthocyanin degradation, which color is a really important trait when we are looking at berries for making wine. But at the same time, I feel that we need to be paying attention to pre-variation heat waves that previously we might not consider that they were so important, and we're seeing that they are playing a pretty big role. But I think both heat waves are having maybe influence in different compounds, but they are both important. I don't know if that answers your question.
Yeah, it does. Thank you.
Oh, go ahead.
That's a question. In the baseline grapes, was there any shriveling that occurred? And I know they were a lot, the yields were a lot lower, but did you observe any shriveling like or raisening of the grapes that are stressed?
Well, we definitely saw that some shriveling happening in the baseline treatment. And also, I would say that we started seeing leaf senescence early than in the other two treatments. So that could also have helped the berries like getting shriveled. But it wasn't a huge amount of shriveling. I mean, this is like from a personal observation. We didn't really monitor it, but there was some shriveling happening.
Okay, yeah, I was just curious because there's some specific rootstocks that seem like once they get stressed and shriveling happens and you water them, the retention of the shriveling to go away, the water's not absorbed back into the grapes. Like I think Cobra 5C is known for that. And I just was curious. It seems like 1103P, I know that's more drought tolerant, but that's all I was thinking about.
Yeah, we didn't see any shriveling in the other two treatments for sure, but we did have some shriveling in the baseline treatment. But again, I don't think it was that concerning. It wasn't a concerning shriveling.
Cool, thank you.
Yeah.
So Malenka, you had a question? If you can go ahead. I saw you actually.
Yeah, thank you. Great talk, Martina. I'm just
Thank
wondering
you.
about the finished wines. I know you said you still wanted to do sensory studies on those. Like, were they all made in the same way? And what, if any, differences do you expect to come from the sensory studies?
Oh, yeah. So, yeah, they were all made in the same way. And we have them bottled, and we're hoping, I mean, it's just like a bummer that we cannot do them this spring. But we're hoping to see differences. And actually, we tried these wines when we did a meeting with Gallo. I think it was back in November. And we, from my perception and most of the ones that actually tried the wines, we already like saw differences like in alcohol content, in also like the aromatics, but I mean, this is also a personal, I guess, comment. But we're hoping to see like in the phenolic profile, like differences in color. Hopefully we'll also see differences in astringency perception, since we're also having different tannin, I guess, synthesis on each of the treatments. So that's what we're hoping to see. I mean, we didn't get to fully run the sensory studies, but we'll see when they happen.
Is there anyone else? Speak
I have a
up.
question.
Yes.
It's Nico Van Bach, Martina.
Nico.
Martina, so I was wondering like what you think about how much is the influence of temperature versus the water stress? Because like, let's say between your baseline and your double X treatment, let's say if artificially you could bring down the temperature in the baseline without changing the irrigation, you think you'll get closer to what you saw in the 2X treatment, or you think there's something to do with it, with the water apply that change things? I was just like wondering if in the future, like when you try to implement mitigations through heat waves, is the only thing that you should be looking at is irrigation, or you should be looking at other alternatives to cool down the system?
Well, I think like they have done also other studies like looking at shade clothing to kind of like decrease temperatures in the canopy. I think the main goal here is decreasing temperature inside of your canopy. I think that's the main driver of all the differences that we're seeing here. And also, I think when we start applying too much water, I mean, we didn't measure shoot growth or things like that, and we didn't get pruning yields because they were hedging so much that it was impossible. But maybe you're also stimulating vegetative growth, and if you don't, most of these secondary metabolites are so influenced by light exposure as well that you can also be affecting your treatments that way. And I think we'll have to look more into that. But I think temperature is the key in trying to prevent these compounds from changing. But aside from water, I think like shade cloths seems to be, now there are these like nets that they use, kind of the same nets that they use for hail back in Argentina, or that seems to be having a pretty good result in lowering the canopy temperature.
Thank you, Martina.
Yeah.
And Joaquin, you had a question?
Yeah, Martina, I had a question. Did you look at the night temperatures? Because I work in the area, and I mean I was surprised last year that during even 105 we still went down to like 60 Fahrenheit at night. So I'm wondering, that diurnal fluctuation in recovery.
Hey, Joaquin. No, unfortunately, we didn't look at temperatures throughout the night, but this year we are gonna put sensors that will log all that data. So we only took temperatures throughout the day.
Okay, perfect. Thanks.
Yep.
Anyone else? Feel free to speak up. Otherwise, I think we'll close by giving Martina a round of applause for her great talk. It's like a Zoom cheers. We can all unmute and clap.
Good work.
Martina.
Thank you.